Okay, this is lesson 7.2, compound angle formulas. Compound angle formulas are essentially equations that take two equivalent trig expressions and set them equal to each other. And they're tools that we can use in trigonometry to take complicated expressions and simplify them, or to find the exact value of a trig expression that doesn't have a special triangle angle, something that we can't or something that we want an exact value for. And there's three different varieties of addition formulas and subtraction formulas, one for each of the three primary trig ratios. So there's both an addition and subtraction formula for sine, an addition and subtraction formula for cos, and an addition and subtraction formula for tan. And the first way we can use them is to simplify an expression, to express it as a single trig ratio. And we can do that if we can identify patterning. So let me scroll down here. For example, in our first trig expression, sine pi over 3 times cos pi over 6 minus cos pi over 3 times sine pi over 6. If we have an expression that looks like this, we can identify a pattern and we can collapse it using the identity, the identity which is one of the addition formulas or subtraction formulas that follows the same pattern. So for example, if I were to simplify this, we got sine cos minus cos sine. And if we look to see which one that matches, we got sine cos plus cosine, that's pretty close. Cos cos, that's not close. These have tan, so it's not that one. Here we have sine cos minus cos sine. And that matches the patterning down here. And as long as the angles match up in appropriate positions, then we're good. Sine A, sine pi over 3, should match with cos A, which is at the beginning of our second expression after the subtract sign. So we have the same angle at the beginning of both, the same angle at the end of both terms, and we've got sine cos cos sine, so we follow this patterning. So what that means is we can simplify this expression and express it simply as sine of pi over 3 minus pi over 6. And if we do a little bit of math here, we can simplify that further, because sine pi over 3 is the same as 2 pi over 6, and sine 2 pi over 6 minus pi over 6 would just be pi over 6. So what do we do here? Well, we collapsed this expression using the subtraction formula for sine. And what did we do here? We simplified the fraction by subtracting it. So two steps. Identify a pattern, apply the proper formula, and then simplify. So let's try it again. This time we've got cos cos plus sine sine. And the first angle matches the first angle, second angle matches the second angle. So cos cos plus sine sine. This is sine cos, that's not right. This is cos cos, but it's minus sine sine. Sine cos, that's wrong. Cos cos plus sine sine, angles match up. This must be a subtraction of cos. So we can apply the identity. Subtraction of coses in this pattern. Our first angle, 4 pi over 7. Our second formula, subtract, is pi over 4. So this first step was just the subtraction of cosines. It must match the patterning exactly. If the angle, one of the angles is slightly off, you can't use the subtraction formula. If the sine's wrong, you can't use the subtraction formula. If the angles are switched in the first one, you can't use the subtraction formula. It needs to be identical in order to use the identity. Now we can simplify our fractions. I'm going to do this one in 2 steps so we can see the simplification. We need a common denominator in order to subtract the fractions, so I'm going to use 28. So that would be times 4 on top and bottom, so that would be 16 pi over 28, minus times 7 on the top and bottom, 7 pi over 28. And if we subtract them, we get cos 16 pi minus 7 pi is 9 pi over 28. Oh, can't see that. There we are. So subtraction of cosines, we use the identity, and then we simplify the fraction. So that's identifying an expression and applying an identity. Alternatively, you can use the identity the other way. You can take an angle, which is not a special triangle angle, and use one of the addition or subtraction formulas to evaluate it. And this is how. So we have to take our angle, 7 pi over 12, and try to turn it into the sum or difference of two angles that are special triangle angles. So our special triangle angles are pi over 3, pi over 4, pi over 6. Pi over 2 is a nice one because that lands on one of your axes. Pi is a nice one because, again, that lands on one of your axes. And those are critical values for sine and cos. We know what sine and cos are at pi over 2 and pi, 3 pi over 2 and 2 pi, because it's, well, either at 0 or 1 or 0 or -1 if you're tracing the sine curve. If you're tracing cos, then it's at 0. It's at a max 1, then 0, then -1, then back to 0, then back to your max of 1. Those are all those critical values that we use to graph sine and cos, so those are nice ones as well. So special triangle angles or any of those critical points for graphing sine and cos, we know how to evaluate. We know what those numbers are going to be. But 7 pi over 12. The way I always look at it is I think I need to break this into two fractions, either adding or subtracting. So we need to start with our 7 pi over 12, and I need to break that up. If I were to break it up into 1 pi, it would be pi minus however many parts need to get you to 12, like 5, because 7 and 5 make 12, and 12 over 12 is 1, so that would make your 1 pi. So pi is a nice number that we know how to evaluate for cosine and sine. But 5 pi over 12, that's not a special triangle angle. So we're not going to break this up into pi and 5 pi over 12. We're not going to do subtraction to get our angle. So we need to break it up into two things that add to 7 pi over 12. So what adds to 7? Well, 1 and 6, 1 pi over 12, not a special triangle angle, so let's not do that. How about 2 and 5, 5 pi over 12, not a special triangle, so let's not try that. 3 and 4, 3 pi over 12, and 4 pi over 12. That adds to 7 pi over 12. And if we simplify those fractions, 3 over 12 is the same as 1 over 4, pi over 4. 4 pi over 12 is the same as pi over 3. What we have here is two special triangle angles. Why is that important? Well, if we apply the addition of cosine's formula, we can evaluate sine and cos of pi over 4, sine and cos of pi over 3. So we can actually get the exact value of cos 7 pi over 12. Let me show you how. We've split our 7 pi over 12 into two angles that are special triangle angles. And we did so by addition. So we need to look at our addition of cosine's formula. Our addition of cosine's formula says that we need to take cos A times cos B and then subtract sine A times sine B. What's A? The first angle. What's B? The second angle. Guess what our first and second angles are? Pi over 4, pi over 3. The two angles that we broke 7 pi over 12 into. So here we go. If we want to evaluate cos 7 pi over 12, we can rewrite it as cos pi over 4 plus pi over 3. Because cos pi over 4, pi over 4 plus pi over 3 is 7 pi over 12. Those are equivalent. This expression is equivalent to, let's use our patterning, cos A plus B, so cos A times cos B, so that would be cos pi over 4 times cos pi over 3, minus sine A sine B, minus sine A is the first angle, pi over 4, times sine pi over 3. So what do we got here now? Cos pi over 4 is something we can evaluate using special triangles. How? Well, if we remember our special triangles, here's my special triangles. If I want cos pi over 4, pi over 4 is here, cosine is adjacent, adjacent's 1 over hypotenuse, root 2. So cos pi over 4 is just 1 over root 2. We can do the same with cos pi over 3. Cos pi over 3 is here. Cos is adjacent over hypotenuse. It's 1 over 2. We can do the same thing for sines, because we know these angles. These are special triangle angles. Sine pi over 4 is opposite over hypotenuse. That's 1 over root 2. And sine pi over 3 is here, opposite over hypotenuse. That's root 3 over 2. And now we just have to multiply and then subtract. So let's multiply. 1 times 1 is 1. So we've got 1 over root 2 times 2 is 2 root 2. Minus 1 times root 3 is root 3 over root 2 times 2, 2 root 2. Almost there. Now we can subtract these fractions. The denominators are the same, so we subtract the numerators and write over one fraction, or one denominator. 1 minus root 3 over 2 root 2. And finally, we want to rationalize our denominator, so we want to multiply top and bottom by root 2. So that means multiplying both of these terms on top by root 2. So 1 times root 2 is root 2, minus root 2 times root 3 is root 6. And on the bottom, 2 times root 2 times root 2. Well, root 2 times root 2 is 2, and 2 times 2 is 4. So this, root 2 minus root 6 divided by 4, is the exact value of cos 7 pi over 12. And that's how we can use these 6 identities to evaluate or find the exact value of trig expressions which don't have special triangle angles. And it's also how we can simplify complicated trig expressions into single trig ratios. That's part 1. Thanks for watching, and I'll see you again in part 2.